Okay, we're going to show you a couple problems here. And then over the course of the next couple days, we're going to take things pretty slow because you are going to need some time to work through your assignments. And I do want to honor people who are choosing to go watch some state stuff. So it says find the area bounded between y equals x to the fourth and y equals x squared or 2x squared minus 1. X to the fourth looks like this. It's like a parabola, but it's shallower on the bottom. Okay? And then 2x squared minus 1, I happen to know that this parabola actually comes up and touches tangent to the side. I know that it actually comes up and touches tangent to the side. And we're going to show you right now, we're going to confirm that for you. So I'm not given any bounds here. And so what I'm going to do is I'm going to set those equal to each other. X to the fourth is equal to 2x squared minus 1. I subtract the 1 over and I subtract the 2x squared over, or I add the 1 over. I get x to the fourth minus 2x squared plus 1 is equal to 0. What now? Yeah? What are my solutions? So that means that 1 is a double solution and negative 1 is a double solution. Agreed? And double solutions mean that there's a tangent touch. So right here, that's going to happen at negative 1, and right here, that's going to happen at positive 1. So which one's on top? Which one's on bottom? 2x squared minus 1. So the integral becomes the integral from negative 1 to 1 of x to the fourth minus 2x squared plus 1 dx. I will now show you a nice trick that I've learned. What do you notice about this area and the y-axis? What does the y-axis do to the area? Yeah, it's symmetrical. Would you agree that the area is symmetrical on both sides? So therefore, what we can do is what? 0 to 1 and double it. Nice job. So that's actually a theorem that I haven't brought up, but when we talk about the definite integral, if it's symmetrical, then you can simply go from 0 to that number and double it, which is a nice option. And some people thought, well, why is that big of a deal? I don't like to plug in negative 1. I like to plug in 0. I'm a lot less likely to make a mistake. Would you agree? Yes. So I'm just going to find this area from 0 to 1, and then I will double it. Good? So I got 2 times x to the fifth over 5 minus 2x cubed over 3 plus x evaluated 0, 1. What do I plug in? Plug in 1, and we get 2 times 1/5 minus 2/3 plus 1. And when I plug in 0, I get 0. Okay? So if we had plugged in negative 1, then we should get the exact opposite. But we don't have to plug in that negative 1. We just the 0 gives us 0. So 15 is going to be my common denominator. So we got 3/15 minus 10/15 plus 15/15. Negative 7 plus 15 is 8 times 2 is 16/15. Now, I brought this up second hour, but every time I get done with one of these problems, you see this unique answer that pops up. It just seems that there's something kind of special about it, doesn't it? I mean, 16/15. That represents this exact area here. I said that, and some people started to laugh, and they said, we don't think there's really anything special or unique about it. Okay. Every party needs a party pooper. That's why we invited those people, so whatever. All right, this is the other example we're doing today. We're not going to go through anything further, just this one. This one is this one's a lot more challenging. What do you notice that makes it different? Very good. What does that mean if we have y squared as opposed to x squared? It's a horizontal parabola. Very good. Every single part of this problem we talk about is important. You will use every single part we talk about. X equals y times, whoop. I'm going to factor out that y, and I get y minus 1. So what that means is that it goes through 0 and 1 on the y-axis instead of the x-axis. Do you think this parabola is going to open up to the right or to the left? It's going to open up to the right. Why? This is positive. Very good. So there's a rough sketch of that parabola. Then I have y equals 2x minus 2. You all know what 2x minus 2 looks like. That's a line with a slope of 2 that starts down here at 1. Or at negative 2, excuse me. So that's what we get. Okay. Now you're used to identifying what's on top and what's on bottom. If you go top to bottom, that has a horizontal thickness of dx, that rectangle. If I draw that rectangle here, I still have a horizontal thickness of dx, but what's on the top and bottom there? For this one right here, isn't the same equation on the top and the bottom? So what will happen when you subtract? It'll cancel out. So it does not work to draw vertical rectangles in this situation. So as Jake said, we are going to do horizontal rectangles because instead of going top to bottom, we will go right to left. So instead of dx, or a horizontal thickness, we have what we call a vertical thickness, dy. Therefore, all of the equations must have a y in it as opposed to an x. So this is y squared minus y, but I can't label the line as 2x minus 2. What would I do instead? Good idea, but no. Solve for y. Very good. So we are going to add the 2. Y plus 2 is equal to 2x. Divide by 2, and 1/2 y plus 1 is equal to x. So this line right here is 1/2 y plus 1. So now instead of identifying the top and the bottom, we're identifying the right and the left. The right function, 1/2 y plus 1. The left function, y squared minus y. Yep. Yeah. So two things to consider here as you guys consider this idea. Suppose I have a temperature of 10 and a temperature of -3. What is the distance between those two temperatures? 13. You took the top minus the bottom, right? So if you think of a number line side to side, if I have 10 on a number line, I have -3 on a number line, I would do right minus left, correct? So that's why we do top minus bottom or right minus left. Andrew? Is that your question? Okay. All right. So now I need to figure out, so I have this integral. I have an integral of the right, which is 1/2 y plus 1, and I'm going to subtract y squared minus y, dy instead of dx. So as you do a dy, you understand everything has to be in terms of y. My bounds also have to be in terms of y. I don't go from x to x. I go from a y value here to a y value there. How are we going to figure that out? Set them equal to each other. These are both x equals right now, right? So we'll set them equal to each other. So y squared minus y equals 1/2 y plus 1. I want to solve that equation. I'm going to get rid of the 1/2. I'm going to multiply through by 2y squared minus 2y equals y plus 2. So 2y squared minus 3y minus 2 is equal to 0. Does that factor? What are my solutions? So it looks like negative 1/2 is going to be the y value here, and positive 2 is going to be the y value up there. Okay. We go from negative 1/2 to positive 2. Sweet. You ready? Let's do it. Integral 2, negative 1/2. 1/2 y minus a negative y. 1/2 y minus a negative y. We got a 3/2 y, got a positive 1, we got a negative y squared dy. Antiderivative, which does not mean you're afraid of derivatives. Very good. 3y squared over 4 plus y minus y cubed over 3 evaluated to negative 1/2. 70% of the AP Calculus exam, you're not allowed to use a calculator. So we're going to do its difficult and evaluate this without a calculator. We plug in 2 squared. Divide by 4 is 1 times 3 is 3. Plus 2 minus, looks like 8/3. Hey, that was no big deal. Negative 1/2 squared. A 4th divided by 4. A 16th times 3 is 3/16. Sounds like a wrench. Minus 1/2. Negative 1/2 to the 3rd. And then make it negative positive 1/8 divided by 3. Yep, 1 over 24. Yeah. So 3 plus 2 is 5. Minus a negative 1/2 would be 5 1/2, right? Or 11 halves. So I got rid of the 1/2 and the 3 and the 2. Minus 8/3. Minus 3/16. Minus 1/24. What's the common denominator with all this? 48. Very good. You're smart. So 11 times 24. 48. I got to multiply this by 16. 8 times 16. 128. 3 times 3. And then get a 2. Word, I made a mistake there, but oh well, we'll see. 264 minus 128. Let's see. 132. 132. 6. 136 minus 9. 127 minus 2. Now, I think it's pretty tough to not look at that and say that there's something special and unique about that answer. I mean, that's pretty cool right there. No. You would still be guessing. You would still be guessing. That's a pretty cool problem. Think of all the math that we've used in order to figure out that problem. That's pretty sweet. you are now able to finish off your worksheet. The answer key was posted here until somebody stole it. Okay. And I've checked it pretty well. I think it's 100% good to go. So we'll see some of you guys tomorrow. Wrestlers, great luck at state. We hope you do well.